Alright class, today you will be graphing on Desmos. I'm going to show you how and where and how to do that. So you're going to want to open this tab. That's your assignment today, how fast is a 9th grader graphing questions. And then you're also going to need your data open as well that we collected last week. So make sure you have those two open. This assignment is going to force a Google Doc, a copy of a Google Doc into your drive. So do that. And when that opens up, I would like you to put your name on it so I don't have to search for it as much. So you can, it says copy of, you can say like your name. So Mr. Bear 2023, yeah, whatever. But yeah, put your name on it. It makes it easier for me. So do that. And then make sure your data is open. So go over here, click to share your data tables. You already shared that. And then you're going to go to whatever class period you are in. It pops up as class period 1, so I'm going to do class period 1. The data should be similar for all the classes. If you do the wrong class, no big deal. So go back to here. Here's your document. So I don't want you to go and log into Desmos, like type in desmos.com. What I want you to do is use this link, and you're going to have a link for walking. If you scroll down to page 2, you're going to have a link for jogging, and you're going to have a link for running as well here. But we're going to do the walking graph together. So click here to go to your Desmos graph, and I'm going to show you how to get all those answers for your first graph, and then you're going to know the process for the other ones. So this is where your data goes, time, distance. I'll show you how to use this slider in a bit, but you're going to go here. You're going to use these distances and these times. And you might be saying, isn't time the dependent variable? Yes, but if you put time on this axis, on the x-axis, you're going to have a formula that helps you find the velocity for this. So I know these go up by 6s, so that's going to be the same for each graph. So 0, 6, 12, 18, 24, 30, 36. Then my time for zero distance is 0 time. And then so I have 2.74. 2.74. My next one was 6.75, I believe. 7.65, okay. 7.65, and see how those plot points are coming up for you. 11.23. So you're gonna have to switch back and forth on your tabs a lot. Get used to that. 14.81. Your next plot point is 18.03. 18.03, and I believe this one was 21.32. So you have your plot points, so great job, but before you move on, you need to line up your line of best fit. So remember, that's just connecting your 0, 0 point, your origin, to your last dot, and it just has to be touching. So as you can see, it says A equals 0.168. You're going to get rid of the lines you don't need, so you need that red line, and that line is going to be your equation. I'll show you where that comes into play in a minute. But it asks the A value for, what is the A value for this graph? The A value can be found on the Desmos website or above the slider. Your A value is 1.68. That is what this is finding for you. That's how fast your walker was accelerating. Then it's going to ask you in number 3, what is your equation? Your equation is just this. D equals AT. Feel free to copy and paste. I don't mind. So the equation that matched my data is, bam, copy and paste, D equals AT. Question 4, rewrite the equation. This time substitute the actual A value in for A. So you're going to write D equals 1.68T, because 1.68 is your A value. And then the distance, this is a really awkward one, but you're going to have to do this. The equation describes the mathematical relationship between the variables distance and time for a walking student. To describe what this equation says about the relationship between distance and time for a walking student, complete the sentence below. So it's going to read something like the distance a walking student is, which is d equals, is 1.68 multiplied by the time, by the time a student walks. So that means every second they walk, they're going to go about 1.68 meters. And there you go. That is your tutorial for graphing on Desmos today.